Okay. Hi, Riley. All right, so one thing, I'm looking at this problem number 1 here, that you want to think about. What does the first derivative, the sign of the first derivative mean, and what does the sign of the second derivative mean? So when I look at that, when the first derivative is negative, it means that the graph is decreasing. So the graph is going to be decreasing. And decreasing could look 2 different ways. Decreasing could look like, it means from left to right, the y values are going down. So it could look something like this, or it could look something like this. And so something that looks like this is called concave up. Kind of looks smiley. Something like this is concave down. And how I know which it is the second derivative, because the second derivative is the rate of change of the first derivative. Like, are the slopes slowing down in steepness, or are they increasing in steepness? So when the first derivative is negative, like it is in this first case, we're talking about concave down. So it looks like a frown. Okay, so that's helpful. So when I go to draw my graph here, and not everyone is going to have the exact same graph, but it should be like kind of an overall similar shape. So we're talking about less than -1. So if this is -1, so less than -1, the graph is decreasing and concave down. So we have no idea what the specific x and y values are, rather, but I do know the graph's decreasing and concave down. So let's just draw something that kind of looks like that. Because the second derivative, decreasing because the first derivative's negative, concave down because the second derivative's negative. And then it continues to decrease, it looks like. So if I go here, from -1 to 2, the graph continues to decrease, but it's changing concavity because the second derivative is now positive. So it's now concave up. Okay, so let's draw where 2 is. So 2. So here's 2. So again, it continues to decrease, but it's concave up. So it's going to look something like this until I get to 2. Now notice, because at -1, it changed from concave down to concave up, then -1 is an inflection point. I don't know if you've talked about that, but that's an inflection point is where it changes concavity. Okay, so it was decreasing between -1 and 2, the graph, but then it was concave up, so smiling. And then it looks like from -2 to 8, so let's do 8, 2, 3, 4, 5, 6, 7, 8. Okay, so from -2 to 8, the graph now all of a sudden is increasing, but the second derivative is still positive, so it's concave up. So let's do the 2 possible graphs for increasing. So remember, these were the 2 graphs for decreasing, or when the first derivative is negative. The 2 graphs for increasing are going to be, I'll do it in red, so increasing means from left to right, the y values are going up, so it could look like that, but this would be concave down. Or it could look like this, so smiling, concave up. And it all depends on what the sign of the second derivative is. So it's telling us this between -2 and 8 that the second derivative is positive. So until I get to 8, so sorry, I'm going to run over my notes a little here. We said we're increasing, okay, and concave up. So it's having this shape right here until I get to 8. All right. And then it looks like after 8, from 8 to 10, we're still increasing because the first derivative is positive, but we're changing concavity because the second derivative is negative. So now we're going to concave down until I get to 10. So let me extend this. 9, 10. So again, it's changing concavity. So this is going to be an inflection point at 8. And it's now the frown, but still increasing until I get to 10. And then it looks like at 10, it now is continuing to increase because first derivative, after 10, I'm sorry. It's continuing to increase. And but it's now changing concavity. So because the second derivative is positive, so concave up. So it looks like, once again, we'll have a inflection point because it's changing from concave down to concave up. So anytime you see a switch of the second derivative, that means a change in concavity. So that means an inflection point. So it's changing from frowning to smiling or vice versa. And anytime you have a change from increasing to decreasing, and this is if it's continuous, then you're going to have a local max or min. So it looks like here, there was only one spot here that changed from increasing to decreasing, or in this case, it was decreasing to increasing. So there, as our graph shows, there's only one, it looks like it's at 2. There's only one local extrema, and it's a local min. Otherwise, we don't have any others. We have plenty of inflection points, but that was the only local extrema, and it was a local min. Okay, I hope that first one's helpful.